Thank you very much for having me. Um, like Cecilia said, my name is Carlos Serrano. Cecilia, I'm gonna start sharing here my screen.
Yes, absolutely. Yeah.
Okay, so my name is Carlos Serrano. I'm a Puerto Rican living in Raleigh, North Carolina. Been living here for almost 7 years now. I've been working with data for around 10 plus years. My career started as a network administrator. Then I switched to DBA, which I spent a good portion of my career as a DBA. Then I switched to engineering and lastly, architecture. I'm a senior solutions architect at Snowflake since December, and I've been working with the Snowflake platform for the last 3 years. I'm hold 2 Snowflake certifications, the core and the advanced architect. And you can find me in my social medias, SQL Insights in Instagram, my channel Carlos D. Serrano in YouTube, or my LinkedIn, which I have seen a bunch of people from here already added me on LinkedIn. If you have any questions, any concerns, or you just want to see some material, just let me know, shoot me a message, and I'd be more than happy to help you all. Today, we are going to be talking about ETL versus ELT. I think that this has been kind of a change of pace of how we do data ingestion. And for many years, ETL was kind of default. Everybody was doing data ingestion or data integration will default to do ETL. And that was mostly to account to the fact that bandwidth was not that great. Moving large volumes of data over the wire was very expensive. But with newer technologies, newer clouds, greater speeds, now we don't have to restrict ourselves to doing ETL. We can leverage the full power of ELT, which I'm going to explain in a minute. So our traditional approach to ETL, we have the normal extract, transform, and load. We will get data from a source system, SQL Server, Postgres, among others. You will transform that data into its final shape and then load it. But what challenges does that represent? Okay, so we have a subset of data that we extracted, we transform it, we load it, and let's say that you extracted 200 million records. After you transform it and you load it, you realized that the transformation was too restrictive, or you needed to do some more transformations. Now you need to go back to the source, extract it again, transform it again, load it again. That was that dilemma that we all had as SSIS users. If we did not have enough testing on our systems, we will end up doing the same extract all over again. And we all knew how tedious it was to spend a weekend doing extractions. With ELT, it's slightly different. We extract the information that we want, we load it into the destination, and then we can run transformations on it to be either loaded into another system or to simply represent it with views, stored procedures, materialized views, and many other database objects, which we can use to transform that data and present it to consumers. In my opinion, the biggest benefit is that gives us the option I can create different transformations from different consumers like the finance department, HR, procurement, FP&A, and all of these different departments can leverage transformations of the same single extraction. So I maximize the use of that extraction from the source system into the destination system. Let me move my camera here so I can see the chat in case that there's any questions. So now that we see some of the benefits of ELT over ETL, so let's talk about the benefits of doing this in Snowflake. Transformations, first of all, can harness the full elastic power of compute in Snowflake. You can have a transformation be as simple as you want and as complex as you want and throw a lot of power to be able to complete this transformation. Multiple transformations can be performed simultaneously without contention. So now I have an extraction of data from my source system, diving into Snowflake, and once I have in Snowflake, I can have multiple systems or multiple warehouses, multiple tasks, running transformations for different departments at the same time without any contention whatsoever. Meaning that I don't have to run my packages serially one by one. I don't have to start a 10 hours transformation job that would start Friday night and Monday morning. I can now run all of those transformations simultaneously and be done with it before leaving work on Friday. Data can be reused. We all have suffered of a transformation gone wrong, and now because the data was in transit from my source to my destination, I have to start my extract all over again. Once you extract the data, you load it into the destination system. If you need to retransform or you need to reset your data, you have that loading point to restart all your transformations again from that point. It is also great to track changes over extracts. Sometimes we don't want to transform the data radically. We just need to know in a time series event, how much are my extracts changing over time? And you're gonna see these a lot in IoT, devices, ledgers, where you just want to track how much is my data changing over time. This is very easy when you're doing ELT because there's no transformation needed from source to destination. Okay, data lineage is very simple, and I think that in the years that we're living right now, where data governance and restrictions and laws against data are getting more and more strict, being able to tell this went from here to here, this happened, this person saw it, this warehouse unit touched it, it's key. Sometimes our transform jobs in ETL were so complex that by the time that the data hit the destination, it was very difficult to know how many steps that data went through before hitting your destination. And let's be honest, 90% of the companies that I've worked for has zero documentation. So keeping track of how my data has been changing over time, it is very difficult. That's not something that you're gonna find if you do ELT in Snowflake, because we keep track of who touched which column, when, where, and from where. So data lineage is key. That leads into governance. It is simplified. Why? Because I can have row access policies in my load that you can still run queries and do joins and do everything without even seeing the data behind it, because the data might be masked, might be hidden. So you can work with data. You can engineer over data that it's still governed by your organization, that you can securely modify, securely alter, and securely query without infringing any law. Okay. A big key is the technology stack. You can do transformations in plain SQL. Not every company out there has an SSIS developer. Not every company out there has someone proficient in AWS Glue, in PySpark, in Python, in Scala, Java, etc. So the very basic language of data, it's SQL. And once you load your data into Snowflake, you can do all the transformations needed in SQL, unless you require any sort of, more complicated transformations. But for that, there's tools like Snowpark, which you can run now Scala, Java, and Python directly inside Snowflake without the data leaving Snowflake whatsoever. So there's still extensibility language inside the Snowflake platform to be able to do those things. And one of my favorite ones, you can augment your data using external data sets. For example, I know of some companies within our ecosystem in Snowflake that they do manufacturing, and a big part of manufacturing are delays, right? A delay can cost millions of dollars in a manufacturing company. So they use data via the marketplace from the weather system that they can correlate that data in their transformations to understand whether a weather event has affected the delay on their pipelines. So Snowflake has a very, very big collection right now of data sets via marketplace. Some of them are free, some of them are paid, but you can use those shares without any ETL. And once you create a share and you share it with a consumer, when data changes to you, data changes to them. There's no ETL so they can get the changes. They are getting a direct access secured to your data with policies, applies, and everything else. So reducing the friction between source and destination is the primary thing in ELT. And there are some workflows right now on the market, like IoT, for example, that might require a small ETL because the data comes in proprietary formats that might not be readable. You get this a lot with sensors. Sensors have their own flavor of JSON, and a lot of them has to go through an IoT core to get that into a readable format that can be extracted. That is different than an ETL. That it's parsing of data to make it readable to be loaded. Another case where we see ELT with some transformation between, it is in streaming pipelines, because there's aggregators like Kafka, SQS. You need to aggregate data so you reduce the volumes through a pipe. Those are viable scenarios when you want to mix ETL with ELT. If there's any questions so far, feel free to put it on the chat. I'll be more than happy to jump into any of the questions. But this is a small slide about the benefits of ETL over ELT. Today in the demo, I'm going to focus on some of the tools that Snowflake allows you to do ingestion and how to do some transformations. And you will see that some of these transformations are just plain SQL. Okay, I'm going to navigate through some of the setup that I did initially, and I'm going to be working within my Snowflake account and my AWS console account, so you guys can see what I am doing live. Some of it I set it up before because it requires some testing before it can go live. So some of it has already been set up, but I want to go over how I set it up, how it works, and some of the perks of setting this data ingestions in Snowflake. Okay, so with that said, it's demo time. So in the setup, I created a new database called MD for Magna Data, right? And I created a database, then I used it. I created a schema called raw. Usually when we're ingesting data, in many enterprise situations, we have 3 levels of data. We have our raw data where we ingest all the data as it is. This might be a pseudo data lake, right? And then we have our conform data layer where we do all the different transformations and we make sure that the data is correct. We place the confirm data there. And then there's the consumer side where we present either by views, materialized views, persisted tables. And that is where we create a presentation layer to make sure that our consumers can use the data that we just created. Before creating any sort of ingestion, I had to create this. This is a storage integration. And a storage integration it's a connection between my Snowflake account and my S3 provider via an IAM role. Instead of me specifying credentials for buckets in every single external stage, I create a storage integration. And when I create a storage integration, I pass the ARN, the Amazon resource number of the role that I'm using. In this case, I'm using a role called Snowflake S3 full. So I wanted full access to that bucket, right? And if you see, I'm saying, okay, I have 2 storage allowed locations. One is financial, and then later I did an alter and I added transactions as a separate location. So I am authorizing this integration to access and assume this role right here on these two S3 locations. Once I create that storage integration, I can do a describe. And if I do a describe storage integration, we're going to see this external ID and this storage IAM user. In my IAM configuration in S3, the only other steps that you have to do is, if you go to roles and I search for Snowflake, on the trust relationships, I am going to paste the Snowflake IAM user, and I'm going to add this condition which says strings equal STS external ID, and this is the external ID of the security endpoint of my Snowflake account. By doing this, I'm creating a trust relationship between my Snowflake account and my own S3 account. This allows me now to create external stages that can point directly to S3 buckets and read directly from S3 buckets without having to pass authentication each time that I create a stage. And this is key because you don't want to be putting external keys and credentials on every single statement that you have out there. So back to the setup.
You have a question, Carlos.
Yes.
Kriparam is saying, how is this secured?
So this is secured via IAM role assumptions. So right now, when you see the IAM, the console management, you are saying, you're telling Amazon, I am coming with this user and I am coming from this external ID. So Amazon is giving you access only if these two matches, and these two parameters are created when you create the storage integration. And when you create a storage integration, you're passing the role that you're going to use to connect on your Snowflake side, the role that you're willing to assume, and it's giving you that keeper value of external ID and IAM user to create a trust relationship between your storage account, your S3 bucket, and your Snowflake account. If for any reason your external ID changes because you drop this integration storage and you now have a new external ID, you won't be able to communicate because all the parameters have to match. Okay, and this is using the backbone of S3 and all the default STS assumed roles that IAM role provides. Yeah, you're welcome. Thank you very much for the question. So once I have my storage integration, I'm going to go here and create two external stages. And an external stage is a Snowflake level object that creates a connection between an S3 bucket and Snowflake. And if you see, I'm saying, hey, storage integration equals the integration that I just created. If I don't use a storage integration, then I need to pass credentials. I need to say a keeper value of secret key and access key. And that is exactly what we're trying to avoid. We're trying to avoid passing credentials to this type of objects. So I'm saying, okay, I'm going to create an S3 sample data. This is the URL. And I'm using this storage integration. And I'm going to create a transaction stage, which points to this other folder using the same integration, because these two URLs are the two URLs that are authorized in my storage integration allowed locations. Okay. So now that I have those two, I can go and do a list. And basically a list, I can go and see what's inside that bucket. So if I run this list, it lists me the files that exist inside that bucket. I am reading that bucket directly with Snowflake to know what it is inside of there. And it tells me that, hey, you have 4 Parquet files. If I go and I do a list on transaction state, I'm going to see that I have 2 files, 2 CSVs. Okay, 1 transaction export for the month of January 2021 and 1 transaction export for the month of February 2021. By the way, the data that I'm using here today, I'll make sure to put it on my GitHub and send Cecilia. So if you guys want to use this to test on your own Snowflake accounts, you might be able to do so. The data that I'm using today has all been generated using Python and a Faker library, so none of it is real, in case that you see some data on it. So, okay, now I have my external stage and I have my security. I can't connect securely from Snowflake to AWS to do data ingestion, okay? Now I need to let Snowflake know, hey, how is this data gonna be ingested? So I need to create file formats. If you don't specify a file format while doing an ingestion in Snowflake, it's always gonna default to CSV. So if you don't want it to be CSV, you have to specify. But within CSV, you might have different options. So I'm gonna create or replace a file format called S3 Parquet, and I'm gonna tell, hey, this is a Parquet. If I am using Snappy or any other of compression in my files, you might specify the compression here, and it will know that the files are compressed, and it will decompress and uncompress them again. Okay. Now I'm creating another file format called S3 CSV, and I'm saying, okay, I want the type to be CSV, the field delimiter to be a comma. I want you to skip the header, skip 1, because the first line is a header. If it is null, I want you to make it, if it is either null capital or null lower, I want you to make it a null field. And if the field is empty, mark it as null, because I don't want an empty string on my fields. And you're specifying different options. You can add compression, you can add many other options in here, and know how are your files structured. Okay, so I have these two file formats created. And lastly, I'm going to create a warehouse, and I'm going to make it an extra small. I'm going to say, hey, you can suspend it at 300 seconds, which is 5 minutes, and auto resume it. Basically, what this is going to do is that if I start this warehouse and I do nothing on it for 5 minutes, it will go to sleep. Once it goes to sleep, you start getting billed for it. Okay, but because it has the auto resume, I can wake it up with the first query. I don't even have to throw a command to resume it. I can just post a query and it will wake up immediately. Okay. So now we have the basic setup of what we're going to be doing today. And let's assume for now that we have a package either in SSIS or Glue or some sort of batch job extraction. And those extractions are sending the data to a data lake in S3. Okay. That data lake could be in S3. That data lake could also be in Snowflake. Snowflake has a utility which we're not going to demo today because it will take another hour to do the demo for it. It's called SnowSQL. SnowSQL is a CLI client. It's a command line client that you can invoke from your tools like SSIS, PowerShell, etc. And you can pass a list of files and upload them directly into Snowflake, but you can also run commands. So with SnowSQL, you could upload these files directly to an internal stage, to a table stage, or to a user stage. An internal stage is very similar to what we created here, but instead of being pointing to some place in your Snowflake, you don't specify a URL. You just say the name, and it will immediately create an internal stage, where Snowflake stores the data in your Snowflake account internal storage, and you can access it the same way that you will do with any of the other commands, but Snowpipe. Snowpipe only works with external stages, and we'll discuss Snowpipe in a bit. You have a user stage that you can access anytime, and you have the table stage, which every table that you create has its own stage. If you want to do like individual loads of data to each table stage and then populate it into a table, you might do so. I haven't found a specific need to use it yet. I find it more useful to load my data into S3, for example, and then query from there, because this is the most common approach in companies. They have their own data lakes. They want to keep using their data lakes, and they want Snowflake to be able to read from it. So now that we have our initial setup ready, who has a question, if any? Okay.
I don't see any question in the chat. Please drop your questions in the chat and we will read them.
Okay, so
There you have it.
Yeah, so I specified that I'm going to be loading data that it leaves in S3 as Parquet and CSV. So if I go to my S3 bucket right now, in my Amazon console, I'm going to have my Carlos Snowflake test bucket, and it has two folders. In my financial folder, there's 4 Parquet files, and I created a file format so Snowflake understands that these are Parquet and knows how to read those. And I created a folder called transactions when I have 2 transaction reports, and these are CSVs, okay? And now that we know that these files exist and we have specified the formats, let's query that data. One of the things that I love about Snowflake is that if you want to read the data from S3 without loading it, you don't need to load it. You can just read it from S3 if you're just doing exploratory data analysis or so forth. So we know that we have 4 Parquet files here. And if you see, I'm going to do a select star from, and I am going to do S3 sample data, and I'm going to specify 1 Parquet file, okay? And then I'm going to open parentheses and say file format arrow function equals S3 Parquet. There are sometimes in Snowflake you need to use the arrow function type. Sometimes you need to use just the equal. If you are kind of wrapping things from a select star from a stage, you need to use the arrow function type. If I execute this command, I'm just reading that single file. And this is going to go and read that file and show you the results of that file. Because this is a Parquet file, everything is going to come as an object. So every row is going to be a JSON object inside your file. You're going to notice that I'm going to ignore this null dask index. Is because I generated a fairly large pandas frame and I use dask to split it into chunks. And it generates this dask index, which I don't like, but so be it. So now I can read from an individual file, but I don't need to read from an individual file. I can just read the entire bucket with Parquet files, and it will go and read all 4 files and just bring the results back. And this is really good when you're trying to see what's inside there. You're just doing some initial data analysis. And as you see, that field is called $1. That $1 is the first column in a data load via copy command. But Snowflake has something that I totally love, is that in files like Parquet, Avro, ORC, it can do what is called schema recognition. So if I use the function infer schema, I specify my location and I specify my file format, I can run this and it will go inspect that and tells me what data types I need to build my table against. So it will go read the metadata of those files and tell me you can build a table with this structure, and it was going to tell me not only the expression, but it's going to give me the column ID, the type, and then give me the expression of how to query that data. And I can do this by that single command of infer schema. Because infer schema is a table function, it gets prefixed with table. In this case, I'm ignoring that null dask index column because I don't need it, okay? But then I could also say, hey, create or replace a table called financial using a template and pass that command that we just used with an array aggregate, right? And this creates a JSON object that gets passed as a template to that create table, so you can infer the schema of the collection of those files and automatically creates a table where that data can fit into. So being able to do schema on read and just have my data safe and not worry if my data changing inside my data lake is going to break how I ingest, it's a big deal. And this is something that you cannot do in ETL. ETL is schema fixed. You need to know you need to know the schema so you can do ETL. ELT gives you that benefit. My schema can drift. I can adjust to schema drift with ELT. With ETL, that requires a deployment because you have to change the packages, you have to change the transformations. Not in ELT. Okay. So now that I have a table created, I decided to go another route because I wanted to reorganize how my columns look, right? So I'm going to use my warehouse ETL WH. And I am going to create or replace my table financial as, and if you see, I'm using those expressions to rename some of these columns. These are some of the things that you can do when you are doing this type of ingestions. You can reorganize how they are. You can change a type. You could rename the column. So in my suggestions, if I run this command again, you're going to notice that the balance date comes as a text, because the way that pandas formatted the string for that date, the closest type was a text, was not a date. Well, I don't want that to happen, so I can come here when I'm doing my text and say, no, this is a timestamp, and I can recast it to a timestamp instead of using text. But I am creating a table from a select. So I'm saying create or replace table as, and I'm passing a select from sample data S through Parquet. So if I run this command, this is going to go read my S through bucket files for that Parquet and create a table that matches that structure, and I'll have my financial table created. When I have my financial table created, that also means that my table is not only created, it's populated. So if I do a select count and counts, minimum and maximums come from metadata in Snowflake, you can get a count of a terabyte table in milliseconds from financial. So we know that this table is 2 million records. That statement took 181 milliseconds to get to know that my table is 2 million rows. And I also loaded 2 million rows in 17 seconds. So having this kind of flexibility of loading data quick, getting stats about my data quick, it's ideal. I'm going to run this statement that says select count star from financial, right? Which is the same one that I have here. But I can also say select minimum, maximum, and count from financial. And because all of these three are metadata queries, they don't take any seconds. They also don't take any compute. There is no compute use when you do minimum, maximum, and counts, obviously without non-aggregated columns, when you're just getting those type of values. But now I can go and run either transformations and do some sort of median analysis. So I want to know by DH what is the median balance, for example. And this takes milliseconds, and that table is 2 million, it's 2 million records. I'm also doing this in an ultra small warehouse. It's an extra small. One of the things that really got my attention in Snowflake is the fact that you can change the size of the warehouse that you're using to query your data like this. So if I need my warehouse to be bigger, I just run an alter warehouse. Now my warehouse is a large, and a large is 4 times larger than an extra small. So meaning that if you run a very expensive query and that query takes a minute with an extra small, it is very likely to take 15 seconds with a large. It's amazing, the way that you can switch the compute power. So now I don't need a large, I don't need to burn those credits either. So I'm going to go back to an extra small, and every query that I knew from now on is going to use an extra small. Okay. If I want to see how my data looks, how my table looks, I can do a show tables like financial, and it's going to show me that I have a table that was created with this timestamp. It's going to show me some basic information. It's going to show me how many rows it has, how big that table is, who's the owner, the retention time, if he has change tracking on, if he doesn't have change tracking on. There's a bunch of other, options to enable on a table. But not only that, I can do a describe. And if I do a describe table, now I can see the actual definition of the table, and I can see all my fields and what can I do with my fields or what's no. If you had fields that have an expression like a computer field, you're going to see it here. If you have policies assigned to your tables, meaning that you might want to have a column where they can only see stars because it's a restricted field, you're going to be able to see what policies exist in the table by doing a describe table. Okay. So this is the very basic of loading data in Parquet. And Parquet, when you load data in Parquet, you're going to see that the data, it is a JSON blob if you don't specify this notation. If I just do a copy from, and let's do that real quick here. So if I do a copy, let's do a create a table financial raw, right? And that financial raw is going to be a raw data. And that is a variant. And I don't usually do like queries like this because this is a way that I failed online every time. But if I do a copy into financial raw, okay, from, and now that from, I'm going to use a select. I'm going to do select parse JSON 1 from, and I'm going to grab this so I don't complicate myself, right? Okay, so if I run this copy into, so now if you see, it says here that it loaded those 4 files with those. Now when I do a select top star from that table, from financial raw, the main difference is that I have only top star. Well, let's do a star and put a limit 100 so we don't run the whole thing. We're gonna get 1 row with JSON data, right? The main benefit of doing this kind of approach as well is that you can still leverage the schema on read. So let's say that some people want this Boolean to be a Boolean, but some other department needs it to be a SHA-1. You can store your data as variant, as raw, and apply the different schemas when you're reading it to send it back to whoever is going to get it. So you enable the power of multiple transformation with schema on read, but it also means that if your schema drifts, it doesn't affect the ingestion of your table because it's expecting that JSON raw to be inserted. So you can deal with data validation post ingestion instead of failing at the front door of the ingestion if you get strict with your schema. So we're living in a world where schemas are somewhat, somewhat flexible with introductions of NoSQL, MongoDB, Cosmos, Dynamo. You are going to get data that it's never going to have the same schema or it's going to have no schema whatsoever. So being able to adapt your table structures to accomplish ingestion of data with drifting schemas or no schemas whatsoever, and be able to do schema on read, drift that data, multicast that data, provide that data to wherever you want to, it's beneficial. And a very, very easy way to see in this is that now I am going to grab these, right? I'm going to grab these results that are here. And I am going to say, okay, now I know that these data looks like this. So I am going to create view. And I'm going to say this view is going to be financial V as select. Well, I got my select from financial raw. If I create this view now, when I query this view, this is going to be doing the same thing that I did in my ingestion. The only difference that I need this to be raw data. That's the only caveat, because my data, my column is no longer +1. And I always say that I'm not going to do live coding, and I always end up doing live coding. Okay. So if I create or replace, and I do now financial raw, financial view. I am doing schema on read from the JSON blobs that I just stored as JSON, as a variant in my, meaning that you might have multiple views with multiple shapes to the same data that you just ingested, and you can create multiple transformations for multiple consumers, from the same data set. So you extract once, you transform multiple times. I think we have a question.
Yes.
So the question says, not related to this topic, but that will be great to know what's the best practice of documentation is, either on ETL or ELT, etc. Any standard template or similar thing. I will say that the documentation will vary depending on the compliance regulations of where you're working at. My documentation varies very different when I'm working with a client from California that is strict by CCPA, because every single thing that happened to the data and the rights to be forgotten has to be there. My only recommendation for you is find a tool that makes it simple, because you are going to be writing a lot of documentation. You don't want to be writing that by hand. Talking from a Snowflake side, we have tools that people can get partners with, like Calibra and Alation, that you can have full lineage of your data. You can get reports of who queried what, when, from where, using what tool. So definitely that type of documentation, try to standardize it and try to automate it as much as possible. Because if you have a good data shop, you're gonna be writing a lot of it. But it is really gonna vary depending on the regulations and compliance rules of where you're working at. There are some places that you only have to specify what data type it is. There's some other places that have to specify what data type under what stewardship, and who see it, who didn't see it, or something like that. We have another question from Wilson. Says, what happened to these SQL queries? Can you save, store, stored procedure like invoke it? Yeah, you can create stored procedures. You can create functions. You can create views. If you're dealing with a table with a lot of records, and we talk about lots of records in Snowflake, we're talking about hundreds of millions. We're not talking about 1 or 2 millions. If we are dealing with a lot of millions, let's say you have a table with 100 million records, and you need to change the way that table is organized, I suggest a materialized view, because then you can recluster that data differently. That is definitely a topic that we can touch another day, about performance in Snowflake and how to achieve, best practices around data structures, because that is a very big topic. We have another question that says, what's the difference between SnowSQL and this SQL? So this is Snowsite. This is the main UI for Snowflake. SnowSQL, it's a client. It's a CLI, a command line interface for Snowflake. You can connect via command line and execute queries, upload files to a stage, get files from a stage directly from SnowSQL. If you need to upload files to a stage right now, the only way of doing it is through SnowSQL. If you want to load data to an internal stage. Yeah, synthetically, there's no difference. The only difference is that this is a different client. It's a client dedicated to be a command line. You talk about ingesting data from IoT devices like a live stream. How do you store data to evaluate the stream? Great question. So usually when you have an IoT device, you're going to have an IoT core behind it, and that IoT core is going to have a pipe. That pipe could be Kinesis Firehose, it could be Azure Event Hub, it could be, you name it. It depends on the structure behind it, right? So usually what happens is that you have something like Kinesis Firehose that makes the aggregation of the events from the IoT device and send that data to S3. And from S3, we are going to see how we can, automatically load data into Snowflake in just a minute. So bear with me and I'll show you how to do it, briefly. But usually the path is to either use Kinesis Firehose to S3 or use something like Kafka, which Kafka can write directly to Snowflake via an integration. And it all depends on the IoT core that you're using. So moving along, we see how we can ingest data. And I think that one of the confusions that we see a lot is that people talk about transformations, and we think that transformations is radically changing the shape of your data into something magical. A transformation can be as simple as casting your data, truncating your data to a different length. Changing the label is considered a transformation. If your column here is first name and your column at the end is F_name, that's a transformation. Anything that changes the shape of the source, metadata-wise, becomes a transformation. And 99% of the transformations to happen to a data can be done in SQL. Even when we use SSIS, SSIS is still doing SQL behind the scene. So being able to create all of this directly in the platform where the data lives is a major advantage because we don't have the transport part. We don't have to wait for the data to go somewhere else to be extracted and loaded again. So let's talk about small transformations, right? I created a date dimension. And this date dimension, if you go to my website, SQLinsights.info, there is a blog post here, all the code to create in this date dimension, it's there, okay? This date dimension, I did adjust to show you guys how to do, certain things. Thank you, Cecilia. And I created this date dimension. Once I have my date dimension, I'm gonna use it here, right? In my transformation portion. So you go and I do a select star from financial. I can see that I have 2 million records in my financial table. By the way, if you see this table, you see that it took 4.7 seconds to run that query on 2 million records. If I run this again, it's going to take milliseconds because it comes from the results cache. So when you run a query in Snowflake, if you run the same identical query within the 24-hour span, it is going to come from the results cache if the underlay data hasn't changed. So I've seen a lot of companies that they have queries that they run constantly during the day, and they have a job in the morning that kind of warms up all those queries. So whoever comes and runs them is just getting them from cache. So we have our date dimension. And in our date dimension, I just created a date dimension that goes from January 2020 to January 2024. And I have my surrogate key for the date, my date, the day name abbreviated, the day of the week, month number, month ID, month name abbreviated, first day of the month, last day of the month, the quarter ID, first day of the quarter, last day of the quarter, and the year. Okay, so that's very quick date dimension, very standard. Some date dimensions have more fields because people like to have other fields. I created that one quickly. Then we have our schema, which is called conform, right? And I am going to create two tables. I'm going to create a table where I say, okay, I want to see the quarterly balance aggregates as the sum of the net balance, total balance, to know whether it's paid or not. And I want to know the quarter ID. I want to know the recording date. When do I recorded this information, right? I'm going to create or replace this table. And this is going to run against my table, which took 1.1 seconds. Have in mind, we're still running an extra small and 2 million records, right? So if I do a select star now from my balance aggregates on the conformed schema, I get my table that has my total balances, the quarter ID, and when do I record at this table. You can do this to do like of a type 1 or type 2 dimension when you do this as a job every quarter, and you can get full aggregates of, thousands of rows, very quickly. And these are transformations. They are not complex transformations, but they're still transformations. So I presented these two, right? And I did this H range table, and let's show you what this table does. So this one's took 1.2 seconds, and let me call it from here. So this showed me within A ranges, what was the maximum, the median, the minimum depth for those H ranges, right? And I created this too, because very easily we could create a task for this one and a task for this one that run on the day at the same time on the same day simultaneously, and you get no contention. Because in Snowflake, unless you open a transaction and you lock something up, which on an OLAP system is very rarely that you open a transaction, you're not going to get contention whatsoever. So many users can query the same data set with different warehouses without running into contention. Okay, so these are very simple transformations done purely in SQL. We could do like a rolling update, like a rolling sum, for example, using window functions. Everything that you will do in T-SQL, PL/SQL, you could do here. Snowflake has a mix of kind of the very good things of T-SQL with the good things of Teradata, with the good things of PL/SQL. For those that do a lot of window functions, and one of the things that I like about, so if I do a select balance, right, from let's say from financial, right? So I have a balance date, but I want to put now a row number over, and let's say partition by, and let's say age, order by, let's say balance date, right? Because I want to get those two fields as RN. Usually when you want to filter something, like this in Snowflake to get the first row for each of these dates, partition by age, you will have to do a CTE to then filter where equals 1. By Snowflake mixing the kind of the syntax, I can do a qualify here. Qualify RN equals 1. And I don't have to do a CTE. I can just run that qualify, and without having to do CTE, I can get that first transaction of each age. Obviously, I did not put age here. But, I could get that first transaction, when it was done by each of the ages without having to do a CTE. So different transformations require different things. The documentation in Snowflake's Snowflake website, it's tremendous. You're gonna find examples for every single command reference. So if you're looking for DDL commands, every single DDL command, every single DML command, it's there. So docs.snowflake.com, I'm gonna paste it here in the chat. It is, oh, Cecilia, you're quicker than me. If you're looking for, for DMLs, I'm looking to do a row number, right? Each of these have examples, and you have pieces of code that you can use to learn Snowflake. They have really good documentation on that matter. So now we have historical loads of data. We loaded all the data that we wanted. Now we want to load data continuously into Snowflake. And this is where the ELT really becomes handy, because you can load data without worrying to transformations and transform it later, okay? So this is where creating pipes comes handy. So now I have a table called transactions, right? And that table has a transaction ID, has a transaction amount and a transaction date. I'm going to create a pipe, and a pipe is not other thing than a Snowflake object that specifies an action between a stage and a table. So if you see I have a create pipe, and it's called transactions ingest. And I say that I want auto ingest, and I'm going to explain what auto ingest does in a second. And I say, hey, this pipe equals copy into raw transactions from transaction state with the file format S3 CSV. So I'm telling create a pipe that automatically ingests CSV files from this stage. Okay, so I created this pipe. Now, if I describe this pipe, and these are the kind of things that I mentioned that I prepare before starting the demo, so you guys can, use all the time. I have my transaction ingest, I have my definition, and because auto ingest is true, this has a notification channel. And this notification channel is an SQS queue managed by Snowflake. What do I do with this SQS? Well, with this SQS, I'm going to go to my bucket, and on properties, I am going to tell my bucket, on my properties, I'm going to tell my bucket, hey, in event notifications, let me edit this one so you can see it. I want you to, when an object is created in an S3 bucket, I want you to send a notification to this SQS channel. So basically, every time that you put a file on that bucket, it's going to fire a notification to Snowflake to let it know that there's something new for it. And it's only going to listen in the stage that you are. So if there are multiple files in an event queue, because you get one per account, each pipe is going to get whatever it is for the stage that they are defined to. So that's a little bit confusing at the beginning. But if you have 5 pipes and all those pipes are pointing to the same bucket in different folders, each pipe is going to grab the message corresponding to the stage in the path that they're specifying. So they're really smart about that. So now I created my SQS queue. I said, hey, Snowflake, there's something ready for you. And I have my pipe. I loaded 2 files before. So if I run this command here, which is using system pipe status, right? If I run this command, you're going to see that there's no pending files. My pipe is running, meaning that it's active. And the last file ingested was this transaction export to 2021_2. If I go to my table, if I can type select from transactions, you're gonna see that I have a few transactions there. I have transactions corresponding to 2 months. So I'm gonna group them by month so I can see how many files were loaded per each month, right? So I know that for the month of February, there was 1,677, and for January, there were 1,485. So now I am going to go to my transactions, which I have here in a little folder, right? And I am going to go to my bucket. And on my objects in my transaction folder, I'm going to click upload, and I'm going to throw the transactions for the month of March, and I'm going to upload that. I can track the progress of that by running this command here. I can check if something else has been ingested. It usually takes about 20 seconds to a minute, to run. There are new changes coming up to this service, which is it's called Snowpipe Streaming, which is going to take things down to 20 milliseconds. So you're going to be able to stream little pieces of information to a pipe without any latency whatsoever. So if I run this here, I have to wait, for it to be caught up by the by that. And usually what I do is that, this is for constant data loading. So if you see here, it changed. It says that the last process file was _3. So if I go here to my table now, the data has landed on my table. I have data from that third file on my table right now. So you can have continuous data ingestion in Snowflake. And this is where IoT benefits. because IoT has an aggregator that goes to Kinesis Firehose, for example, and they can aggregate the events of an IoT device for every 15 minutes and then drop it into S3, and we get it. And every 15 minutes, you get ingestion from an IoT device from that aggregator that gets connected to the core. So right now, I know that I'm receiving data constantly, but what happens is that I have now data that might be in this table and I need to move it to the other table. And this is when things get complicated, right? In parentheses, there's really not a lot complicated in Snowflake, is that, okay, now I need to process that new data. How do I know when there's new data? There's a thing called a stream. And a stream is a change data capture object that you can put on top of a table. So I created this stream. It's called new transactions, right? And what I'm going to do with this stream is I'm going to say create or replace. So I remove it completely, right? Create or replace stream. And if I do a select star from my stream, which is a queryable object, read-only queryable object, you're going to see that my stream is empty. There's nothing on it. I am going to create a table, let's say conformed dot transactions. And let's see, like raw dot transactions. What I'm doing with this is that I'm creating a table with the same structure without any data. Conform, oh, got a space over here. Create table, where did I create my, yeah, raw dot transactions. It's my schema. Let me make sure that my, oh. So I created a table now that it is identical to my other table without anything on it. So now I'm gonna go ahead and say insert or a copy into, copy into conformed dot transactions from raw dot transactions. Oh, let's do from select. This is for external, so let's just do an insert. Let's not complicate ourselves. Insert into conform dot transactions, select star from raw dot transactions. So I inserted all. So now those two matches, right? But what happens if I go now and I grab my data from April and I throw it in my S3? Now I know that eventually my data here is going to change because I'm going to have data here that I don't have in my other table, right? So if I go here and monitor, I'm going to keep monitor until I see number 4 here. And this usually takes, like I said, usually takes around 60 seconds to show one file to the other. So while this refreshes, anyone has a question, that will be the time to ask. Okay. So while questions arrive, my file has been ingested. Okay. So now, if I go in here and I say, okay, I want to see my select group from transactions, and I can see that I have data for the month of April, right? But now in my stream, there's data pending to be processed. So my stream contains the rows that are inserted into that table that have not been consumed yet. If you see, it says that the metadata action was an insert. So these is the table, and these are fields corresponding to the CDC changes. So now I know that there's data in that stream that I can go and process and throw somewhere else. So now I can go here and say, now I can go here and say insert into conform dot transaction C, select transaction ID, select from, and let's grab my, and say transaction ID, transaction amount, and transaction date from new transaction. These, a DML like this will do what it's called consume the stream. The stream, after you run a DML, moving that data somewhere else, is considered consumed. You already grabbed what was there. If you need to run multiple transactions on top of a DML of a stream without losing the stream, you need to wrap all the different DMLs into one transaction. So open begin, try and run all your ingestions and then commit it, because that keeps the stream unconsumed until you finish it. But if I run this now, you know, number of rows inserted equals 1,601. So now if I grab this, right, and I paste it here, and from transactions here and change it to from conformed dot transaction counts. If I run this one first, I have this amount. If I run it on the second table, I have the same amount, because now those two tables match. But if I go to my stream, now my stream is empty because I consume what was in that stream. But I prefer to go get data from a stream that has 1,600 rows that have to go and query a table with a high watermark to know what has changed. Is a much more efficient way of doing new transaction processing. Another cool way is that if I go now to my transaction table and I say delete, or let's say update, let me run a quick update here to get a table. So let's say update transaction, set transaction amount equals $5.5, where my transaction ID equals this. And I'm gonna grab this transaction ID and I'm gonna throw it here. This will create an update, right? It says number of rows updated. Because when I created my stream, I said insert only. It doesn't care for that. It is not going to record that one. If I go here and do a select star from transaction, well, I created before I did the insert only. If I do insert only, it will ignore these. But because I created before running this, I did not add this flag. It shows here. So if you see now on my stream, it says that the data changed, and it shows you a deleted and an inserted row, because when you do an update, you're effectively deleting a record and inserting a record on the same placeholder. For the metadata is update flag is turned to true, meaning that these two changes are part of an update. So far, we've seen that we can load data quickly. We can do schema on read and not have to worry about our schemas drifting, and always adjust the schema or assign multiple schemas to the same data set by using schema on read. And we can also ingest data continuously by using Snowpipe. There are other methods of ingestion like JDBC connections, ODBC connections. You have Kafka, which uses behind the scenes the Snowpipe API. You have an API, the SQL API call. You can do read, writes, deletes, and inserts via REST API using the SQL API from Snowflake. So you have many methods. Most of them lie around using ELT because we want you to harness the power of Snowflake by loading your data here and then running all the transformations and everything that you want on top of your already seeded data. In a world where data keeps growing and growing and growing, running ETLs, in my opinion, is more costly than running ELTs, because you're gonna end up running the same extract several times until you get it right. In the case of ELT, you have to worry about getting your extract right, and then you can retry all the transformations that you want without having to worry that you have to go back to the source system and getting the data. Also allows better for multi-processing and batch processing. In Snowflake, there's very common to do micro batch processing where you have hundreds of records at a time. And instead of doing a big push at the end of the day for your data warehouse, you can have your data warehouse be 1 hour behind your production system, or 5 minutes behind your production system. I work with companies where our ODS, our operational data store, and our OLTP database, they were 5 minutes behind. So as data was happening in production, that data was coming down the pipe via ELT and was being represented in Snowflake in less than 5 minutes. This means that I can take all the reporting that I'm doing on the UI, and instead of saturating my OLTP databases, I can repoint all of those to Snowflake and do all my live reporting out of OLTP, knowing that they are about 5 minutes behind. So this is a short demo of how we could do ELT, how we can do transformations, how we can do continuous ingestion, and I threw the little streams bonus because I know that as you start ingesting more and more data, you want a method of only processing what has changed. So if you have any questions, now's the time. I think you can open the microphone, and whoever has a question, please do so.
Yes, I'm gonna open the microphones. Let me look for this function. There it is. You have microphones if you want to ask a question, or you can write it in the chat. Or suggest any future topics that you would like to see in Snowflake.
Carlos, this was pretty amazing. You ought to be wearing robes and a wizard hat.
Appreciate it. Appreciate it very much.
Hi. Hello. If you update a record in the CSV file and upload again, what will happen in Snowflake?
So what will happen is that they will get a new notifications, because when you do a put, if you update a record in the CSV and you put it, usually what happens is that the ID of that document in AWS changes. It is always very, that's when you have to adjust some of the notifications. We recommend using the notifications only for put, because when you version a document, that counts as a put if it is a new upload. If you modify in place, which S3 doesn't allow you to modify in place, but if you're like in Azure where you can modify in place inside the storage account, that's slightly different, and there's some caveats around there. But for the most part, it will get a new version and you will get a new message in the queue. Also, one of the last things that I forgot to mention is that if you have unfrequently changing data and you have a stage, so let's go back real quick to my worksheet where I have my query data, right? I can take this right here where it says financial table, and instead of doing a create or replace table, I can do a create or replace external table. And this external table, I'm not going to do it now because I don't have all the perms set up for the external table. But if you do an external table, this actually creates a table where the data is not in Snowflake. It's a persisted object with that schema pointing always to S3. So you can have a Snowflake table that is not, the data is not really in Snowflake. It's in S3 and it's pointing to your data in S3. Okay. Cecilia, thank you for pointing that. Please join the Snowflake community. You know, we have a very active community. If you have an error, you're going through something, you cannot figure it out, you post a message and I am sure that someone will answer. You know, we're constantly engaging with the community as a solutions architect. We try to find ways of you know, helping people engage in Snowflake, you know, the best they can. So if you have a question, feel free to put it on the community and someone from the Snowflake community will indeed help you. Any other questions? Thank you, Jesus.
A question from Wilson.
You say that you can assign a stream pipe to a function. Well, not the streaming pipe. The streaming pipe is an object that has a copy into. Usually what you do if you need to run functions on top of your ingested data is that you run, and let's go here where it says pipes. Usually what you're going to do is that you have a task, and that task has a function. There is a function called select stream. It's called system stream has data, and you put the name of the stream. In our case, will be new transaction. I cannot remember if it's system or give me 1 second, because that is one of those commands that I don't run that often. Actually, this is a good case. If you go here and you say stream has data, you're gonna find immediately examples of how to do this. So if you grab this guy and you say, hey, show me an example, it is gonna show you exactly how to do this kind of thing. So I'll grab this from here and I'll paste it here. And I had it right, I just didn't have the semicolon on the top one. So if I do this, this is gonna return true or false. So right now it has true. This select stream has data can be the flag to determine if a task that you have scheduled to run, let's say you have a task running every minute, checking if there's new data. You can do that and it will check if the stream has data and then run the task. If in the next iteration, the stream has data is false, then you will immediately, discard this task. And then in that task, you can have your function doing stored procedures or doing something to process your data. Stored procedures and functions in Snowflake can be in different languages. You can write a stored procedure in SQL, which is Snowflake scripting. You can have a stored procedure reading in JavaScript, in Java, and Python. Okay. Same thing with the functions. You can have a UDF function, a tabular function, a UD tabular function, and a scalar functions, and they can be reading in JavaScript, Java, Python, and SQL. So depending on your language choice, you can write them. Cecilia, we could definitely do a different session to talk about that type of objects, because they will take an hour by themselves to talk about stored procedures. Especially now that, Snowpark Python is in public preview. You can run full Python workloads inside Snowflake and run full data analysis inside Snowflake using Python without having to move the data outside of Snowflake. So that is great. Marian Pachon says, when we have corrupt data, what are the best strategies to handle these situations and how we can see traceability of the situations in Snowflake? It really depends on where your data is getting corrupted. I see a lot of places that the data get corrupted when sitting to S3 because they extract with a code page, and the methods that they use to upload the data, if they use like Python or they use PowerShell, PowerShell and Python, when you use the Boto or the AWS SDK, it has some encodings. And if you don't encode it correctly, you can end up changing the page from 1252 to UTF without noticing. And then you get some corruption, and you get some weird character happening there. So this is when using the select from the stage is very helpful, because you can query the data from the stage with different file formats and play with your formats without loading it, and see if using different file formats helps you. When you are declaring a file format, and this is a good question because this leads into this, in this file formats, you can specify an encoding. So if you're using an encoding like UTF-16, UTF-8, Windows 1252, ANSI, you can specify the encoding here if you're using a non-standard encoding, and make sure that Snowflake can read that file with the right encoding type. Otherwise, Unicode characters might come up as an interrogation symbol or things like that. But I will say start tracing from the source. Start tracing from how the data looks in the source, in S3, then in Snowflake, and you're going to be able to find where the data is changing, or where the corruption is happening. You can also use the validate copy method, and it will tell you if it is throwing off any UTF errors in the process. Any other questions?
I see a lot of thanks to Carlos.
Yeah,
And,
thank you very much for having me.
Yes, I want to thank everyone for being here today, and especially thanks Carlos.
Thank you.
This was amazing, very valuable, and I look forward to more presentations. So if people are interested in other topics, or even an introduction, maybe there are people that are new to Snowflake, what topics would you like to see about Snowflake?
Definitely, I'll be more than happy to come here and join.
Yeah, this was amazing.
Any other day.
Last chance for questions. You can go on mute, or you can drop the question in the chat.
Yeah, I put on the screen my social medias, my Instagram, my YouTube, and my LinkedIn. In my Instagram, there's a mix of English and Spanish. I do collaborate a lot in the Spanish community of data, so most of it's in both languages. So feel free to jump in and let me know what you would like to see as well.